Hello friends, I'm Sudhir Agarwal from TeleEdu Consulting. I feel glad and privileged to welcome you to the video classroom session conducted by myself. Today I'm going to talk about the very basic and preliminary concepts about IP addresses. I'm sure that this video would help you understand the world of IP addresses in a better way. IP address is short for Internet Protocol Address. It identifies or relates to a particular computer or device on the planet Earth. IP addresses would identify basically three things about the computer: name of the computer, location of the computer, and route to reach that specific computer. This information would help other computers to connect with that specific computer. IP addresses help transfer of data between different computers located at different places. In layman's language, data here refers to the information intended to be shared. In this slide, a person in India is sharing some details with a person in Seattle, America. Any communication would involve minimum two people or entities. Two more things are needed to complete the communication: a message or information and the carrier of that information. Let me explain it by referring to a postal message delivery. Here we need a paper where the data is written or held and an envelope packing to carry that paper, basically piece of information. To ensure the safety and security of the information, the envelope or packet is closed. There are two addresses written on the envelope: the receiver's address to ensure the communication reaches the intended customer, and the sender's address just in case of failure encountered while sending, the envelope is returned to the sender. Here we are talking about two addresses. The address to which the information is being sent is called the destination address, and the address from where the information is being sent is called the source address. These addresses are always unique. IP addresses also bear a lot of similarity to this analogy. In this slide, the letter goes through different locations to finally reach the destination address. The in-between locations forward and route the letter to the next location after noting the destination address, and this process continues till it completes. The sender need not bother about knowing the details of the in-between locations. Communication via IP addresses also bear a lot of similarity to this letter delivery analogy. In this slide, another example is shown where we connect with people by dialing the telephone number of the person to be contacted. The dialed call is routed via different in-between telephone exchanges to finally reach the intended person. Similarly, the communication in Internet also reaches the intended server by passing through various in-between routers based on the destination IP address. Till now, we have understood that IP addresses are critical to connectivity between different computers. Here we are talking about IP version 4. IP addresses can be written in binary and decimal formats. Computers and other digital gadgets understand binary format, while we the people are more comfortable in decimal format, as this has been the language in our education system. Here IP address is shown in both the formats. IP address is of 32 bits in binary format. 8 bits are equal to 1 byte. So this would mean IP address consists of 4 bytes. The 4 bytes are separated from each other by periods or dots as shown in the slide. Let us now understand the basic composition of the IP address. In this slide, IP address is shown in binary and decimal format. Let us understand the composition of sample phone number to understand the IP address details better. The initial numbers in telephone number identify the area code. Like in this example, 011 is area code for Delhi. The rest of the number identifies a particular person in Delhi who is allotted the number 6190, 6198. This detail plays a very vital role in call routing. Likewise, the left side bits of the IP address points to a particular network and is termed as network ID of the IP address. The remaining bits identify a particular computer or host inside that network and is termed as host ID. The division of bits into network and host ID depends on the IP address itself, and we'll talk about that in the subsequent slides. There are 5 classes of IP addresses from class A to class E. The first byte of the IP address decides the class of the IP address. I hope you remember that there are 4 bytes in IP address. The details are shared in the next slide. The network ID and host ID of an IP address depends upon the class of the IP address. Like in class A IP address, the first byte is network ID and the remaining are host bits. In class B IP address, the first 2 bytes are network ID and the remaining are host bits. In class C IP addresses, the first 3 bytes are network ID and the remaining are host bits. Class D and E are used for different and specific purpose. Class D is used for multicasting and class E is reserved for R&D, research and development. The IP addresses are managed and maintained by IANA, called IANA organization, which is Internet Assigned Numbers Authority. Every class of IP address have fixed range which gets identified by the first byte of the IP address. The slide here shows the ranges for all the 5 classes. Like the class B IP addresses range from 128 to 191 in the decimal format as shown in the slide. For a better understanding, you may please also notice the bit pattern for the first byte of all the classes. For example, class C IP addresses will always have 110 as the starting 3 bits for the first byte. The slide also shows the host range against each class of IP. In decimal format, the maximum possible number is 255 and the minimum possible number is 0 for the IP addresses. Likewise, in binary, the maximum byte is when all the 8 bits are 1s and minimum when all the 8 bits are 0s. There are some special IP addresses that are meant for very specific usage. IP addresses starting with 10.x.x.x or 172.16.x.x or 192.168.x.x are always used for computers inside the user's private network. These IPs are never allocated on the WAN side. IP address 127.x.x.x is always used for the loopback testing to check the working of the software loopback of the computer. IP address starting with 169.254.0.0 or x.x is also referred to as a PIPA IP, automatic private IP assignment. In case of failure of the DHCP server to allocate IP to the computer assigns itself an class B IP of the range 169.254.x.x for maintaining the minimum connectivity. Now these above IPs or ranges cannot be used for any other purpose apart from above. There are 2 types of IP addresses, namely static and dynamic. Let me take an example of travel by car to explain the concept in a simple manner. If we have to travel by car, we have 2 options. Either use our own car or use the taxi service. If we use our own car, the type of the car remains fixed. In case we use the taxi service, the type of the car might change as the travel agency controls the allocation of car. Whatever option we use, travel will happen any case. Static and dynamic IP also behave exactly in the same manner. Whatever IP we use, out of static and dynamic, connectivity will happen. Then why the fuss? The logical reason is the limited availability of the IPv4 addresses, and everyone cannot be allocated a static IP. To ensure the adequate availability of IP to the users, the IP addresses are segregated into static and dynamic. It works on demand and supply principle. Static IP means fixed IP and it remains same. It doesn't change during the usage. Users using static IP have the complete ownership of the IP, and that IP address cannot be allocated to any other user on the planet. That would surely invite higher price because of limited availability. Now if users opt for dynamic IP, the IP address can change. The ownership of the IP and the discretion to allot is with the service provider. If a particular user connection is off, the service provider can allot the available IP to the other active users. That would mean that every service provider keeps separate reserved stock of static IPs and cannot allocate it to dynamic users, while it uses lower stock of dynamic IP addresses to manage higher number of dynamic IP customers, as all of them won't be simultaneously on. Now we can understand why static IPs are priced higher than the dynamic IPs. Now, how should the user decide which IP to go for, static or dynamic? Let me explain static IP first. If user has a requirement to access the device or his computer at his office from network outside of his private network, that is, from the public side, might be his home, then he has to request for static IP from his service provider. It's same as if we have to reach a particular destination. We can only succeed in reaching that address if the address is fixed, that is static, and correct. As shown in the slide, user can access outside network from his private network, that is his computer, and can access his computer from outside his private network. So both sides the communication is on. This is the advantage of having a static IP. In case the user has to access the normal internet sites and has no requirements as such to access his private network from outside, there is no need to go for static IP, and dynamic IP would suffice, and it would also save some money. As seen in the slide, user can access the outside network from his private side, but his computer cannot be reached from the outside. So we have understood how to go for static IP or a dynamic IP. So basically it is the user who decides on the type of the IP addresses based on his access requirements. IP addresses are managed at the global level by an organization named IANA, IANA. It's headquartered at California in the United States of America. IANA has divided the entire world into 5 different regions from the point of view of IP management. The regions are shown in the slide. India is part of the region named APNIC. That's all for the basic introduction of IP addresses. I hope that you have liked the video and it helped you to better your basic knowledge on IP addresses. Should you wish to provide your valuable feedback or comments, kindly share at sudhiragar@gmail.com. Thanks for your time and patience. Goodbye for now. Thanks.